Okay. So, how much delay and how is it working? Is the sound okay? Sounds like it. Alright. So let's share the link on Twitter. Sharing the link on the Exercism discourse now. And in the Discord, in the Gleam Discord. To go. Is there anybody viewing this stream now? No, doesn't think so. Already. Yet. Yet. Like Yahtzee. Okay. It doesn't seem like there is anybody yet. If anybody is here, don't hesitate to say hello in the chat. Waiting a little bit to see if anybody pops. If nobody is showing up, I will start. I guess the exercise in about 3 or 4 minutes. So this yacht exercise, it's basically like Yahtzee, if you know the Yahtzee game. You throw dices and you put them in a category. So in the category of the ones, you have to do how maximum number of ones. In the category of twos, you have to do maximum number of twos, etc. Then there are other kinds of combinations, like the house, where it's 3 cards, 3 same cards and 2 same cards. Fourth kind, where it's 4 identical cards and another one. Little straights and big straights, which are suits. Not suits, yeah, straights. So following numbers like 1, 2, 3, 4, 5, or 2, 3, 4, 5, 6. Choice, I guess it's a joker where you can put anything, and it's the score is the sum of all the dices, and the yacht or Yahtzee in the Yahtzee game is like 5 identical dices, and it's the one combination that gives you the most points. 50 points here. So if the category is not satisfied, the score is 0. Okay. So we are given the different value of the 5 dice, and the category, okay? And we have to return the score. All right, so I guess we have to check that the dice are valid for the category, and then if it's valid, what score it is. Can assume that always 5 values will be present. The value of each will be between 1 and 6. Okay, so no bad data, not bad input. Okay, that's fine. The dice are not ordered. Well, okay, it's fine. So at least we don't have to make game theory algorithm and try to choose the combination and try to choose the category for each of the dice rolls. We're just given a roll, and we have a roll and a category. Category is already decided, and we just have to count the points. Okay. All right, so these are the different categories defined already for us, and the score function. So given a category and a list of dice, what do we want to do? All right, and it's said that the list of dice is already correct, so we always have 5 dice. So I guess we could pattern match on the list of dice, and then try to check if the dice the list of dice is correct for the category, if it's valid. So how do we do that? Do we want to do the pattern matching now, or do we want to do all the pattern matching in one big pattern match? one big case, or do we want to split it in two cases? And if you want to split it in two cases, do we do it by category or by dice? I think we can do a case by category, because there aren't that many categories and we can handle a few of them in the same case, I guess. Right, so we'll do this. We do by category. So case category of ones or twos or threes or fours Actually, yeah, there is no need to split the different categories, because we'll have to convert the 1 or 2 or 3 into a number, and if we have to do that conversion, like, we basically can do that conversion right now. So once what we can do is we can also pattern match. Do we want to split the list into a tuple or arguments right now, or do we want to keep the list for now? I guess we can keep the list, because the list may be useful later, and for things like numbers we don't need to split it to check the different patterns. It will be easier to work with the list directly, so let's keep the lists right for now. And so we will count so the score will be the number times the occurrence of that number. So 1 will be 1 times count 1 in the dice. And we can copy paste this line for the other numbers. 2s will be 2 times count 2. 3 will count the 3s. Or hi Haley. Nice to see you there. I'm wondering why you are in the chat, but in the analytics it's not visible. Like, I still have 0 viewers. It's weird. Or maybe you just came and you're gone. I don't know. Okay, we'll see. She'll respond sometime. 3 fours. So I was saying that we could do this exercise, which consists in scoring the points for the Yahtzee game. So it's quite straightforward. We can pattern match on the different category first, and then like apply some different rules for each of the different cases. For now, I envision that I can do the same thing for 1 to 6, and then we'll have to do something different for the different categories, different combinations that are a bit more complex. So I was just doing that. 5 and 6. 5 and 6. 6 is 5. And then now we'll return 0 in any other case. All right. So what we want is to write this function that counts the number of times one value appears in the list of integers. So obviously we haven't written this function yet, so it will be unknown. Yeah. So is there something to count stuff already, or should I write it? Length. I guess we could use length and filter. That's one easy way to do it, I think. Not the most effective one, but yeah, we could do it. Filter the number and then compute the length of the resulting list. Hi, I don't know who is the second person, the second viewer, but yeah, hello. Okay, so let's write that function. Fn count takes a number and a list of dice, and it returns the number of times that numbers exist in the list of dice. So it will be lists dot filter. Yep, filter. And I have to import Gleam list. Okay. So let's import Gleam list. List dot filter dice, and function is like this: function x equal n. I think that's correct. And after that, we can just compute the length. Can we do it in a method way, or no? I don't think so. There is no method in Gleam, I think. Okay. So, well, pipe and list that length. Is that it? We'll see. All right, it compiles, but obviously we're not passing the tests. That's normal. But I think we are passing all the normal tests. 1 test, 2 tests. Yeah, I didn't see those in the test results. So seems like we are passing those tests. Ah yeah, 29 tests, 9 failures. Okay, 9 to go. Right. Oh, this is the summary. Nice. Okay. So after the 6s, we can do the full house. And let's add a line there. House. Let's call it full house score of the dice. we'll have to check if it's valid and then count the score. So score dice, return an integer. Right. So full house, 3 of one number and 2 of another. Okay. So the list of dice, the dice is a list of int. Can we pattern match? No, I don't think so, because if we pattern match, we'll have to take into account both the number and the position. It will be a bit lengthy. Maybe what we can do is sort the list and check that we have 3 of the same and 2 of the same. Maybe we can do that. So what we could do is, okay. We want to check if it's valid, and then if it's valid, if just the total of the dice. So case valid full house of dice. If it's true, then it's list.sum of dice. I think that's the name. Oh no, int sum, okay. Int sum. Int sum dice, otherwise just 0. Right, then valid full house returns a boolean. What's the type for bool? Bool, gleam, bool. Okay. So we say that we can sort the list, and maybe we can say that they are sorted already there, and we'll sort them here. So sort list.sort. Okay. Here. Let's sort. Okay. Please. Okay, so now we have to check how many different. Oh, is there a group function? That would be nice. Group, list group. Oh. List A. Take a list and groups the values by a key which is built from a function. Initial value order. Map by key. Okay, so for each element we find a key and then it builds a map. Okay, Okay, maybe we can do that. Because we don't care about the orders of the elements, just that the count is okay. So I guess we could do that. We could group them. Oh. And then we'll just have to check that there is a group of two and a group of threes. Because if we use the sorted route, what we will have to do... Oh no, once we have sorted, it's easy to solve it with the pattern matching. Yeah. We'll just pattern match, it will be easier. So, case sorted, nice. Off. Here we go. So how do we pattern match? I think it's like this. A, B, C, D, E, F. No, E, 5 values. So if we're in this case, we just have to check that A and B are equal, D and E are equal, and then C equal either B or A, and it'll be good. So case A equal B and how do we do and? Then double, okay. And B equal E. Right. Then it's only true if C equal B or C equal D. If we have this, then we have 3 of the same and 2 of the same. Sounds good, right? Okay, let's see if we pass the full house tests now. I was not expecting this. List int. Ah, I need a parenthesis here. List int. Okay. I was not expecting this. Ah, no, okay. True. When that's true, it's this, and once that false. Actually, we don't need this case here. It's just this and this and either this or that. Right. So we don't need this anymore. Parentheses. Oh no, not parentheses. It's curly braces in Gleam. Expected 2 arguments. Valid full house. Or is it list.sort that expects 2 arguments? Oh yeah, there is a compare function. Okay. Is there any example? Yeah. By int compare. Let's just do it here. This dot sort dice by it compare. Because the sorting is in the validation logic, so let's keep it in the validation logic. Right. And 8 failures, but I don't see full house failure here. I guess we have the full house right. All right, next one. 4 of a kind. Or of kind. So at least 4 dice showing the same face, but it can be more, right? I guess if it's more, it counts more. Total of the 4 dice. Ah no, it's total of the 4 dice. So if there is 5 dice, it's still total of the 4, which are the same. Okay. 4 of a kind. 4 of a kind. Score. Four of a kind score. Do something like this. Four of kind. Case valid. No. 4 of kind. So how can we do that? How can we do that? We could sort again, but yeah, it's not really. What can we do? We could sort. If we sort, it's only correct if. All right, let's do this. case. List.sort. Nice. Okay. Off. Something. Otherwise, 0. Now is A equal B and A equal C, A equal D, A, B, C, D. Then the score is 4 times A. If it's not the case, so no, let's do exactly like before. So we have B, C, and D that must be the same, right? Because otherwise it's not sorted. So B equal C and C equal D. And then we have either A equal B or D equal E. If we have at least one of these, we can use value of B to compute the score. If we don't have any of these, it's just 0. Right? I think that's right. List.sort. Oh yeah, missing the comparison function again. Here we go. And yes, passing the test for the 4 of a kind. I think so, yeah. Okay. Now, little straight or big straight. So this one is easy, I think. No, is it? We'll see. What's the name? Little straight. Missing T. Straight. Right. Can we do the same thing for the little and the big straight? I think so. So little straight. Yeah, there isn't. It's just there is one option, so we don't even need to do anything special. We could pattern match it here directly, so let's do that. Category dice, and here we don't care, here we don't care, here we don't care, here we don't care, no care, no care, here, no care, and then boom, 1, 2, 3. Oh no, it's not sorted. Huh. It's not sorted. Let's sort it then. Let's sort it. So we can do it once and for all. Okay, we sort the dice, and then yeah, so the dice are sorted, but can we like replace with or dice? Replace. Count. Dice, we don't care. Full house. Yeah, we care. Full house. Because we don't have to sort it anymore. It's already sorted. And if it's already sorted, it's just sorted dice. Can we get rid of this whole function? No, I don't think so. We still need to check that there are 5 elements in the lists. Or could we? I think we could. Full house. Yeah, we could check here that there are 5 elements already. Yeah, we'll do that. A, 4, 1, 2, 3. Hey, we need the elements then. Okay. A, B, C, D, E. A, B, C, D, E. Okay. A, B, C, D, E. Full house score. B, C, D, E. And then it's just checking this case, this, and boom, no need this function anymore. Full score. And so here it's the same. Fourth kind. A, B, C, D, E. Fourth kind. It's just this, right? Get rid of all that. Okay, that's cleaner. 3, 4, 5, and that's 30. Sorted dice. In some, yeah, now it's just A plus B plus C plus D plus E. Sorted dice. 21. Yeah, we don't care about the fact that it's sorted in this place. Why did I change that? I don't know, because the dice is an immutable list, so I don't need to change it. It's just, yeah, nice. So here we go, doing the reverse of what we just did before. And nice. Replace, 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 replace. Nice. Expected to, yeah. Okay, 5 failures now. We got the little straight right, big straight, will be easy. It's just 2, 3, 4, 5, 6. Big straight. Yep. And then choice. So choice will be the sum, so we can do it at the end. And we'll do yet before. So yacht. Oh no, because yeah, there are cases where we don't want this. Okay, let's do it in order, in the order. Choice easy int dot sum. Nice. Oh yeah. Okay, 2 failures. The yacht test. So the last one. Yacht. And yeah, A, B, C, D, E. And then yacht score A, B, C, D, E. And the yacht score this one is easy. A equal B and D equal E. A, B, B, C, C, D, E, E. And it's how many points? 50. 50 points. What? What's wrong? Yacht is not full house tests. Ah, right. In the full house, we have to check that B and C are different, or C and D are different. Huh. So in the case B equals C, we also must have C not equal to D. And in the case where we have this, or we have B is not equal to C and C equal D. I think that's correct. Yay! And we're good. We're good. Let's see how other people have resolved this exercise. Community solution. Oh, we have a kind of a compact solution compared to the others. That's nice. Let's see the solution of Eric. It's usually a nice one. So, one score single number, right? We did something similar. Score full house. Score four of a kind, score. Okay. So, score single numbers. Filter. Yep. I think we did the same. Score full house. Dice with count. Okay. Dice with count. Dice group. Okay, so the group function that we looked at before. Then it's mapping over the groups and counting the number of elements of each group. Okay. Map to lists, and then it's sorting the lists by the second element, so the count. So we can be sure that if the count will be increasing. So it doesn't have to pattern match 2, 3 and 3, 2 in case they are sorted in the reverse order. Okay, that's a good one. Score fourth kind, dice with count. Okay, so this dice with count function is reused quite a lot. So if it's 5 numbers and then 4 numbers, okay. Number times 4. Sounds correct. And then list.sort, okay. We did that. Big straight, okay, did the same. Choice, easy. And yacht. Least unique dice. Oh, that's a good one. Unique. Removes any duplicate element. Oh, nice. Okay. So remove any duplicate element, and if there is only one left, it means, yeah, the 5 dice are the same. Okay, nice one. Dice with counts. Cool. And we have a new badge. We have the functional February badge. Yeah. Published 5 exercises in the functional language February. Nice. I think I already had published 5 of my exercises for this month, because now I have 6 of them. Is it published, published, published? The padding one I didn't finish. Completed. Publish, 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 publish. Okay. I guess one of them does not count for the function of February badge. Or, oh, maybe it has to be the exact exercise that were listed for function of February, which is like the yacht was one of those. So I think like all of them except Hello World. Or maybe Hello World doesn't count. Yeah, that would make sense. Yeah. All right. I think yeah, I will stop here. And oh no, let's see at what's reserved for next month. What do we have next month? Function February. Okay. List of research, YouTube channel, forum. Where's the list for next month? I think yeah, there is an Excel document with I don't know why it's not listed here. Yeah, not including Hello World. Wait. Let's see. Yeah, there is the sheet. March. Okay, mechanical March. So we have C, C++, D, Go, Nim, Rust, VLang, and Zig. So I already know C, C++, and Rust. Then I'm not really interested in D. Go, no, I don't think so. And so that left us with Nim or Zig. I think Zig is I've always been interested by the guy Andrew something. Andrew Kelly, yeah. Andrew Kelly. I think I'll try Zig for next month. Zig CC, yeah. I'll definitely try Zig for next month. Seems like an interesting replacement for C, so yeah. That's settled. Okay. Yeah, so I'm done for this month with Gleam. It was quite a nice language. I struggled a bit at the beginning, but at the end, I think I got it. It's very similar to Elm in a lot of ways, and yeah, I think it's a nice complement language to Elm for the backend. Now, I mean, we just have an there was just an announcement yesterday that Evan Shaplicky go to backend. Yeah, there was the announcement 2 days ago that oh no, not 2 days ago. Okay, I don't know. Evan is going to present something for Elm in the backend, so that's exciting. But I don't think it's gonna compete with Gleam. I think it's gonna be its own special thing. Like Evan likes to do some things that are very original, so we'll see. Exciting, but we'll see. Alright, that's all for me. Good luck to anyone else doing the 12 in 23 exercism challenge. And yeah, see you next month for Zeke. Bye bye.